嗨，各位观众，线上的观众们，午安啊！今天又来到我们这次的新的 webinar 系列啊。那今天呢，主要是来介绍就是关于高通量的在线的监测与控制培养微生物的反应系统，主要是做微生物相关的一些reactor 的部分。那这是我们非常荣幸的邀请到 Beckman 的那个 Joseph Leung，他主要是在负责就是在微生物相关的一些领域啊，还有今天呢会主要是在这台机器呢，主要是在讲说跟微生物的一些监控数据、pH 值，还有温度，以及就是培养的整体的系统。那对于就是这个部分有非常感兴趣的人，我们都可以一起来参观。然后如果有任何的问题，我们都可以在线上再做一些询问。那等等的话，也是在那个YouTube 或是 Facebook 上面的直播部分，你可以留下你们的讯息，然后我们可以在会后进行 Q&A 的讨论。好的，那在一开始之前的话，我们还是希望大家请务必填写一下我们的那个问卷，那我们就有机会送一卡通哦。那请大家等一下呢，在会后一定要保留到最后，我们一定会送上一个非常精美的独家设计款的这个一卡通。好的，那我相信呢，时间的关系呢，我们还是话不多说，那我们就赶快来邀请我们今天的主讲者Joseph，那为他请他带来我们非常精彩的演讲。哎，Joseph，嗨
，Hi，Thank
you，Thank you。
Okay，
那接下来的话，我们就把时间全部交给 Joseph 来为我们带来非常精彩的演讲哦。好
，Thank you. Okay, good afternoon, everyone. Today I'm going to introduce that we have a new instrument called the BioLector, which is a microbioreactor that can help you to do some kind of online monitoring and help you to do some kind of screening to help you for the future for scale up and make sure that you have a very good microbiome fermentation for the future. So just a little bit talking about the IP. This is the information from Beckman Coulter. So from Beckman Coulter, our mission is to make sure that we are answering the life's important scientific healthcare question. So that's why we will keep monitoring different instruments that can help you for the future. So this is the topics that I will talk about in today's talk. We have a little bit introduction on the bioreactors, what exactly the technology is, and some other additional things like how to connect with the automations and other things. So from the introductions, the first idea is why and how we need these kind of instruments. And for the now or maybe in the future, we all know that from the past we have used a lot of the earth resources, but for the future we know that bio will be something that everyone will be want to have, like the biofuel. So we know that the original diesel and all that kind of things maybe run out one day. So if it is possible to do some kind of biofuel, it can be help the environmental, not even biofuel like the drugs and chemicals and even some polymers that can be some biodegradable or from the process of the bio that can help the environmental a lot. And we know that the trends and the demand for the biotechnology is especially some like genetic engineering. They want to have more diversity to how to help the new drugs or some kind of thing, and also some kind of we need to faster to the development to help to target for the market. And also now biotechnology actually is still in the development step, so we also have a lot of early bioprocess development now, and which will require much faster. So what about the situation now? I think that maybe a lot of you already doing this kind of fermentations or reactions for the drug as microbiome, this kind of thing. But the problem is it quite laborious. You need to have a lot of people to monitoring. So and also you're doing the cell culture or the microbiome culture that will require a lot of reagents, consumables, and most likely it need a few days for a life cycle. So we need to speed up. And what is the solution? The solution from Beckman Coulter is we have a new instrument that can be do a very fast and efficient instrument. And the most important is it also can help you to be a cost-effective development for the thing. How we can do that? Inside the instruments, actually, we are using the well-plate method where we can do a very high polarization mesh reactions, like you can be doing the fermentation at the same time. It will be 32 times or 48 times from the shake fast you're using. And besides, we can do a lot of reactions at one time. The volume for the working reaction is quite small. You can see we only require 800 microliter to approximately 2 milliliter. So in this case, it can save you a lot of reagents and consumables. And because we're using the well plate, actually you can see that it is quite automations. And from the automations, we can also have some of the real-time measurements that at the moment, maybe you need to input a lot of offline measurements, or you need to get the sample out of the reactors to get the data. So it is sometimes difficult to monitor. So in this case, we want to help you with this instrument. It is very easy to handle, and you do not need to do special calibrations, and you don't need to do a lot of tube electro settings. And in this means you do not need a lot of people. One people is enough to monitor instruments, and then even we have very high quality data from that. So that's why we introduce this is what we call the BioLector XT, and we classify it as a microbioreactor. So we can do a lot of things by online monitoring, like we can do the biomass monitoring. At the same time, we can have the pH DO measurements, and using the Optox method, which I will talk about a little bit more. And even we can monitor the fluorescence from the different wavelength, so that it can help you to suit your fermentations to make sure that they are in the correct wavelength. And not only the online monitoring, and we can do some kind of control about the what you are doing. Like we can control the shaking frequency. So just like the shake fast you're using, we can also control the shaking of the well plate. And in the instruments, we can control the temperature, and we have gas concentration control, and even we can control the flow rate of the gas. And now we also can talking about a LAMP module that can do the enumerations, and we can have a little bit feeding for the wells, and pH monitoring for each of the wells. So in general speaking, we can do different gassing, and we can make a protocol very easy for you to do and combine different feeding profiles in one cultivation, and then you can do the same time monitoring to see if different methods or different parameters, what will the changes of the data, what you will do from your microbiome. So let's see what our microbioreactor can do. So inside the instruments, we can have the temperature control, which will be suitable for most of the measurements already. And then we have the humidity, so that all the gases can be humidified. And we can do the more on-time, real-time monitoring, like the dissolved oxygen and the pH measurement and the biomass. And we do not need special dilutions. And if compared to the OD600, we can do up to approximately 250 for the OD values. And we are talking about that we can monitor different wavelength by different fluorescence. That actually is just talking about getting some different filters, and we can do the monitoring. And last but not least, the measurements or the whole fermentation, we are doing the shaking at the same time. The shaking is non-stop, so this is to make sure that everything will be very good, even though we are doing the measurement, and to make sure that the oxygen transfer is good enough and we do not stop it. Maybe if we stop it, there may be some problems of your of the growth of your microbiome. So this is the basic feature, and we have an optional what we call the microfluidic module, which can have two additional methods. One is pH control, and one is the feeding. Actually, we have what we call the microfluidic is to control the amount of different reagent adding to the wells. So I will have a little bit more discussion on that. And beside the basic one, this microfluidic module, we also have another one called the light array module, which is specially talking about the light irritations, and it allows that approximately like algae and cyanobacteria that they are more sensitive to light. So if we are doing different light, what will be the differences, and so that we can see what will be the changes. So basically, the measurement is just the same, but we can do some kind of adding different things for that. So inside the instruments, we'll talk about the microfluidic module, we have talked about the light array, and also in the regulations, we can also control about the oxygen, the carbon dioxide, and even if your cultivation is anaerobic, we can also introduce the anaerobic culture module for you. And we also have different kind of well page that can be capable for you to do some low pH method. So we have talked about that, and the main reason that we have this module is hoping that the pH regulations can help you to have a flexible and feeding profiles, and the profiles we have may have different types, like we can add the pH, different pH, like the constant, linear, or exponential, or even though you can have combination of all these methods, and these are all can be used with the anaerobic module, so that in this case you can, even though without the oxygens, what will they come to? And this is the new introduction of the light array module, which we can set up with different light, so that like the photo flash density here, we can set a different density, and compare the sunlight is 2500, but we can even set higher than sunlight, so that we can do some kind of day and light changes to see how to simulate the real time, like what they are doing in the environment. So I'm not going to talk in detail. So if the future, if you have any interest in these kind of instruments, you can talk with our partner about tools. But now this is some talk about how we can adjust the illuminations so that it can be used for the make sure that the light is good. So we have talked about the light. We also have the gassing module, which can help the customer to control among the oxygen level or the carbon dioxide level. So we have quite a broad gassing ranges. You can see we can control the oxygen level and also the 12% of the carbon dioxide. And also, this gassing module, this is some kind of optionals that we can, according to your need, we can set up different type of module for your measurements. Like we can do the up regulations for the carbon dioxide and also for the oxygen gas, and we can also do the down regulations. And we talk about that we can also do the anaerobic, which will be connected to the nitrogen gas to make sure that they do not have any oxygen inside. So this is talking about how we can help for the gassing, because we are using a gassing lid, so that it can be make sure that the environment is sealed and we can control amount of the gas for that, and it is controlled by the instrument, so it will be very easy to monitoring and control about the gas. And this is something of the instruments. You can see the below one is the well page, and the upper part will be the guessing lead. So after we put the guessing lead on each, so we can control them and with quite an easy way for the monitoring. And maybe you will ask about how and why we do the measurements. I will talk about a little bit about the technology you're using. So what we are helping you is maybe in the common fermentation technology now you're using, maybe you're using this kind of bioreactor. So you are only can do one measurement at the time or one fermentation at a time. But what we are using is a 48 well page. So you can see that means you are doing 48 fermentation at the same time. And we have introduced a measurement method called optops. So now maybe when you're doing your fermentations, you need to add different electrodes inside your bioreactor if you want to do online monitoring. And it will be quite difficult because you may need some technicians to monitoring and need to do the calibrations and make sure that everything is good. But from us, this is the well page, and if we magnify the well page, and you can see that every well page we have below, actually the below is a transparent part, and we can check with different parts of what exactly we're measuring, and this is what we call the optops. So maybe we can look a little bit closer. In the optops, we can measure is like the DO, the biomass, fluorescence, and pH value that can be measured in different parts of the optops. And this will be the online monitoring so that you can see about the data and how about the is the timing, so that the x-axis is the time, so we can see that when the fermentation, when your microbiome is increased in the biomass, at the same time we can see that the DO is decreasing because it's using the oxygens. And how about the pH value? It will be a little bit dropping, so maybe there will be some thing that already produced inside the solutions. And we can also see the fluorescence, so it is also have the same more or less as the same trend like the biomass that will be increased. So this is the way that we can help you to keep the real-time data to see how exactly the reflection of your fermentation. Okay, a little bit more about the opto technology. We talk about that we have a transparent well bottom, so we will use different kind of method. And like when we're doing the measurement for the pH and PO, this is an optic cable, so we have the emit light there, and then it will reflect the data and receive that, and then we can calculate for the pH and the DO for this part. For more information, yes, we can tell you that they're like using different LED lights and how we do the calculations. But I think that at the moment, the most important thing is, yes, the well page can do the monitoring for DO and pH on the real-time basis. And beside that, we can do the fluorescence. So it will be the same using optical cable to reflect the light and receive the data, and then we can do the calculations according to the filter we use. And beside that, we can also do the biomass. So here the biomass, and we're measuring the scattering light. And yes, I would say that at the moment, because it is a little bit different from the traditional method, but if we doing some kind of comparisons, to the OD600, and we can see that the linearity actually is quite good. So in this case, we can also say that the OD method and the scattering method is quite comparable. And like this is the talking about the correlations for the biomass concentration range. So we can see the OD and the scattering, and the R square number can be 0.99 for that. And also we can help you is we have different type of well page for you. Beside the normal one we are talking about is a circle one. We also can help you to introduce another web page. It's called the flower page, and this is a quite an interesting thing that, and we can see from the difference for the measurements. This is upper part will be using this kind of circle well, and the lower data is the data we use for the flower page, and we can see that the y-axis is the scattering light, so we can say it is talking about the biomass, and from a certain time actually you can see it will go to some kind of a bottleneck that the biomass cannot increase, or the increase rate will be slower. However, if we change to another flower page, and we can see that they will grow much faster. In this case, we know that this is the optional limitation about the round geometry plate. So that's why maybe we can know that if we can increase the oxygen, or we increase some kind of method to talk about the oxygen transfer rate can be higher, it can help for your fermentation. So this will be our flower page. So the volume actually is more or less the same, but a little bit lower in the total volume, but it can have a higher OTL, the oxygen transfer rate, so that it can get you more oxygen. And if you using our instruments, we also can help you for different type of plates and optopes layout. Like we have different pH value, or some customers actually do not need to measure the optope. They just want to measure the biomass, or some of them want all of the measurements. So we will have different type of optopes for that. And also we have different type of flower page and round page to help the customers. So from the data, we can see that the flower page will have much higher oxygen transfer rate compared to the round page. So this is the round page data. So in this case, yes, we'll talk about that. We can help you for very fast measurements, and we are doing 48 data of compared to you doing one bioreactor. But how about the scalability? This is, I think, is the most important thing that most of the customer, besides find the screening or to find the correct formulations, what they want to have is if it is scalable. And we have a lot of data compare from other different peoples that are doing the journals already, that we can compare that we are doing 1 mil fermentation, which can compare to a 20 liter. So it can be a 20,000 time scalability. So just think that before we do the scale up, and we are doing the checking, we are doing the formulations, and compared to the cultivations we do per week, our insurance can help you for only one plate. You already can do 48. And if you do more cultivations, yes, it can be up to 240 times of the reactions, where compared to the shake fast and bioreactor, we are much more superior than that. So a little bit about the measurement examples. I'm not going to give you a very detailed information. If you want the detailed information, you can contact us. But just to let you know that, like the cone screening, and this is some kind of the data that the scattering light measurement of the 48 parallel cultivation. So this is talking about more or less the same method. So we can compare the different data in 48 different wells, so we can see that the data is quite similar. So that means that these situations can give you a very reproducibility on your cultivation. And we can do media optimization, like we can check with different media, which media can give you better. So you can do sometimes you do the induction for that and see what will be the biomass for the data. And you can see that there will be a shift in growth and for here. And this is very important because this can only be seen by this kind of real-time data, because normally you will not monitor the data every moment, but our online monitoring can help you to see if any changes, any shaping during any different times. And this is talking about the detection of the mineral nutrient requirements. So we can check up with different milligram per liter of phosphate added to that to see what will be the differences from the scattering light, that is the biomass. And we talk about we can do anaerobic fermentation. So just like the name, this is a very easy to understand. This is talking about doing something without oxygen. So what we can do for that, we have another gas lead that can help the customer to silk the oxygen input so that it will continuously adding the nitrogen gas inside. So this is something that we can help the customers to make sure that they will be for sure it is anaerobic. So what we need to do is prepare the media, anything in some kind of the box, and then to make sure that they are all nitrogens, and cover with our anaerobic lid and put it inside the instruments. And then connect the instruments with the nitrogen gas. We can for sure that the whole fermentation will be in anaerobic condition. So this is the example that we have used with the feeding of the glucose and alkaline for that. So we can see that is the data for them. And also if we change a different type of the measurements of another type of microbiome, so what will be it look like? So this is the anaerobic method, that if your fermentation is really need to be no oxygen. And beside that, some other maybe like algae. Algae is also one of the very popular research now. So this is the algae cultivation with the BioLector. And we have talked about the instruments a lot, but something that how beside 48 times more than your shake fast, what exactly we can help you. This is what we call the microthreading. This is talking about we can add the pH control of feeding so that you can have some kind of full bioprocess control for that. So what you can see is this is a little bit different from the well page we have, because we can control the amount of thing. So how to control that? So we have seen this before, but if you want to change adding, so this is some kind of very micro tubing which is inside the well page. So these kind of micro tubings can help us to transfer the liquid that we introduce in the reservoir wells to the cultivate wells. So we define the well page. The upper two parts will be the reservoir well, and with a lot of these kind of micro tubings, we can add the sample, add the material in the reservoir to the well page. So this is the closer look of the well page. And what can we do for the well page? You can see that we can add different type, like one of the row is the feeding well, and one of the row can be the pH solutions, so that we can ask them to add the sample. So this is the cross dimension of our well page. So this is the reservoir well, and this is the culture well. So when the liquid go inside, we are using the air pressure to get the pressure to the other side, and then we close the first places so that to make sure that all the liquid will stay inside and will not go to the wrong places. And then we release the pressure and get all the liquid and go inside the culture well. And we repeat the same process again so that we can continuously to boom this the material in the reservoir well to the culture well. And we can control the amount of the of the reservoir to go in. We can do by exponential. We can do is a linear adding rate or by a constant rate, so that even though not only these three methods, we can also do some kind of combination of the three feeding mode also. So in this case, we can do some kind of what we call the DO triggered feedback. So the instruments can do is monitoring the amount of the dissolved oxygen, and when it is down, it will trigger the feedback and ask the instruments to add some kind of the feeding to that. And this for this one, we were adding the glycerol so that we can do this is what we call the DO tracker. So this is also this is another example, which will be the E. coli of the DO tracker feedback. And so you can see when the DO is dropping, then we'll ask the instruments to feed, and then we also control the pH value with the sodium hydroxide. And beside the DO tracker, this is the PO controlled batch, so we can control the pH and different value to see what will be the change, what will be they look like. And we talk about we can continuously adding the sample, adding the material in the reservoir. So this is talking about we are continuously adding the sample and what will be the changes. And we can see that the DO will drop suddenly and the biomass is getting up. So most likely it is using up some of the DO and to do the increasement. And this is also another idea of the DO triggered feedback. So you can see this is as some kind of checking the DO, because the DO will change according to the fermentation method, and then it will trigger us to add more feeding the glucose and sucrose inside, so that we can see about how it grow about the biomass of the sample. So generally speaking, this is a very small scale that to do the cultivation. And because you can see we are talking about approximately, I would suggest is less than 1 mil is good enough to do the process, and we can control with the pH, and we have 32 wells to do the measurements. So yes, although it is not 48 now, but in this case we can have more flexibility, because we can do the pH method and we can do the feeding method, so that we can do some kind of checking for the what will be helping the customers to do the best of the measurement. And if you say that too well of adding instrument is not enough, we can also help you for another thing is what we call the RoboLector, which will be combine our instruments if with our automation system. So this is a small video. So you can see that from the video, we can connect with the automation, although the video actually is the previous version of the instruments. But now you can see in this picture, this is connected with our latest model, the BioLector XT. And from that, what we can help you to do is we can do more information from that, like the inoculations, inductions. And yes, we've talked about the pH adjustment, but in the previously, the microfluidic model, it will only have the two wells, but now you have more freedom to do the pH adjustment, and at the same time, it's doing the feeding and other method. And if you see from the video, you can see that when we introduce a sample inside the BioLector, the shaking is still on. And this is actually is quite important because we do not want to interrupt the fermentation at any time. If we stop the shaking, the oxygen transfer rate will be different, and we do not know what will be the happen for your cultivation. Maybe it is positive method, or they will have some negative or effect for that. We do not know. So that's why in the whole process, we do not stop the shaking. This is to make sure that everything will be good enough for your cultivation. So you can see this is a example of the layout, so that maybe you can have the different type of thing inside, like doing the sampling, where to put the samples, and what is the target, and about all this kind of thing. And and all these kind of informations will be controlled by our software. So our software can help the customers to monitoring or to schedule how we do the measurement. So this is some of the result. So this is the cultivations. This is the cultivation details, and we are talking about the dosing volume can set as just a 5 microliters, and we can see how the changes, like this is the GFP here, and this is the NADH. So there's different wavelength, so we can do the measurements still on the online measurements. And the media screening, this is the E. coli fat batch cultivations, and we can have a lot of parent data so that we can make sure that they are not only one time off data, they can be comparable to see if everything is monitoring in a correct rate or not. So the applications for the BioLector is more or less the same from the BioXT, but with more informations, like we can do more media optimizations because we can add more, and we can do much more feedback, and we can do the inductions, which previously is not easy to do. So that's why this microbioreactors, what we offer is some kind of new possibility. For the general model, we can do high throughput cultivations, which compared with we can do 48 wells at the same time, and we can do the online monitoring, so that it is some kind of scalability to help you. And with an options, which will be the microfluidic module, that means that you can add individual pH control or feedback processing, so that we can do some kind of DO triggered feedback measurements, or control the pH to see the cultivation. And even more, with the BioLector, we can help you to additionally automate the sampling, and also the inductions and automate feeding, so that, generally speaking, it is equal to the fully controlled and automated process platform. And maybe we have a little bit more discussion about the data, maybe what exactly the instrument's doing. Like this one, this is the cultivation with the filamentous fungi. So this is a reproducible growth for 6 repeaters, so that it is a 7 days cultivations. So we can have the data actually, even though not only for a few hours or 1 or 2 days. The cultivation monitoring can as long as 7 days or even more, like some kind of cultivation, maybe even more for 10 days or more. So we can still help the customer can do all the monitoring, and then we can do the pH value and DO value also. So that if you need it, we can also have different kind of signal to do the monitoring of the growth. So this is a method for that. And to show the reproducibility in the biomass, so we can talk about using different string and just compare the biomass so that to see which one or which string can help in this environment better. So this is two different types. We talk about the flower plate and we have talked about the round plate. So we can do the comparison with the biomass in different type of the measurements. So that depends on what you want to do. Yes, you can still see that the flower page will be more effective than the one rail page, but this is all can be optimized by your measurements and from what you want to see. Okay, thank you very much for your attentions, and this is what I want to share for today.
Okay, Joseph, thank you for your presentation. 现场的大家有没有什么样的问题，都可以在那个 YouTube 跟 FB 上面留言。然后不管用中文、英文都可以，就是只要有任何问题都可以提出来。Okay. And Joseph, there is some question. It's about is this bioreactor have the shaking? Can use the shaking during the culture?
Okay. At the same time, yes, I would like to introduce our product specialist, Ilot. He is in the call now. Yeah. So maybe I will let Ilot to do some kind of answering of the questions.
Sure.
Yes, hi. Thanks for the Joseph. Itself, it is a screen, and so that actually which is inside. So process from time 0 to the end of the experiment, which is keep shaking. So it depends on your microorganism that you use. You can set up the speed up to 1500 RPM for the whole process. Yes, so the answer is yes.
Okay, thank you, Ilot. There's some more questions about that. Is this machine needs to be use the cleaning reagent, or how to keep this bioreactor to be useful?
Okay, I agree. Generally speaking, we are using the well page. So in some sense, if you prepare the sample carefully, and everything should be only in the well page. So it is not really touching the instruments. So unless yes, you if mistakenly that some of the spilling, and I would say that we just use the normal cleaning procedures for your microbiome is good enough. So it is not really something very difficult to do because mainly you're just handling the well page. And I think that most of the time when you're handling your well page, you already have a very good SOP already. So for real case, I'm not really seeing that we need to very special maintenance for that. If do you have any add on for that, Isla?
Yes, it pretty much what it is as the machine, the consumable, the plate is the only hardware that interact with the microorganism. So and it's supposed to be inside. So if anything outside, then there must be some kind of mistake. Yeah, so we just focus on playing for the machine. If you really want to clean it due to maybe the dust and maybe particle from the environment, you just using some water and the tissue paper to wipe it. Yeah, just very general, just like cleaning a table.
It's quite convenient. Okay, and there's a more question is about that. Our client have some questions about pH ratio OD, and how long does it need to take to test it?
So I give for you, I love.
Okay. Okay, right. So the minimum cycle, which is around 3 minutes. 3 minutes for each reading. Okay, so for example, if you want to measure biomass and also want to measure pH and DO, so the fastest speed, which is 3 times 3, which is 9 minutes. Okay, so another good thing you actually can especially for organism which is very slow, maybe up to 7 days or 10 days, you can decrease the measurement time, maybe for every 10 minutes or maybe for every 20 minutes. So the fastest speed, which is 3 minutes for each parameter. So in general, we're using 6 filter model, which is the maximum number that we can put into the XT. So that will be 3 times 6, which is 18 minutes.
OK， 不晓得这样子有没有回答到您的问题？对，那我们这边的讯号可能有点不太好。对，那如果没关系，这个部分的问题的话，我们会在会后再提供给你。如果之后我们有再帮你跟他们做询问。Okay, and there's some more question is about what is the smallest volume of microfluidic well plate feeding alternate to the hollow?
So I think I love this is talking about the feeding. So what is
Yes,
the
feeding,
smallest
yeah.
volume for the feeding?
For the smaller volume, we're talking per stroke. Per stroke, it is around 0.016 microliter.
Okay, thank you. There's a more questions about how many microfluidic conditions are available in one experience. It's been said, may I change the reservoir solution to add different supplements during experience we set in the beginning?
Okay, so the microfluidic condition actually, because just like we said that we are using the well page with only 2 reservoir wells, and the other 4 actually can be set independently. So generally speaking, you have 32 different type of measurements in one well page. But if you talk about the reservoir resolutions, in some sense, you want to understand what you are doing. So we already set the supplements or the liquid you're using. So it is very seldom that you will change in the middle. So in this case, we will say that it is not a good idea to do so because you will lose monitoring on what you are doing. And so in this case, we will say most of the measurement is already set at the beginning of the experiments. So in this case, I don't see that we should do any changes of the reservoir.
Okay, there's lots of questions. And our client has another question is about that. can we take the culture bacteria out and to do a fallow analysis? Is that able?
Well, actually, we are just doing the fermentations inside the instrument, so most likely the answer is yes. But maybe I thought you can add some more information for that.
Okay, so technically it is a reactor which is in a micro size that is below maybe 1 to 2 mil. So after the experiment, after the test, you can get the plates and then you open it up, and then the medium, which is exactly where you are expected from the flask or some conventional bioreactor. Of course, you can extract the medium for the further analysis, such as dry freezing to get the balance. Or if you want to, you even can go for the MS and other and anything you can think of. Yeah, sure, because it is basically a bioreactor.
Okay, thank you. I here have some questions about that. Your plate have the oh, there's another question. For the second question, given that the anaerobic condition in the microreactor is only limiting pure N2, have you tested or evaluated the more strengthened anaerobic microbes which may need to mixture of entire gas? It's a quite long question.
I can take this question. So at that moment, we only can use the device with carbon dioxide, oxygen, and nitrogen gas. Okay, so nitrogen gas, yes, we should use the with high purity. Otherwise, that if the impurity may do some damage to the machine itself. And also for the CO2, which is up to 12%, it is kind of accreditation, kind of safety. We do not want to suffocate the area that are around. And those are only gas that we can only use at this moment. For the mixture, if you're using CO2 upregulation or downregulation, actually you are mixing the gas from the atmosphere, that means from the environment, and also the CO2. So in order to achieve a specific concentration, and also similar to the oxygen downregulation. So those are the three gas that we are now to use at this point: nitrogen, CO2, oxygen, and the gas and the air from the environment.
Okay, thank you for your answering. Oh, okay, and because of the time, so we're maybe closing our meeting. So 非常感谢大家，就是今天的，就是因为时间的关系，那大家就是非常踊跃的回答非常多的问题。那如果真的还有很多的问题的话，就是再麻烦大家就是在那个就是我们的问卷当中再提出来，我们可以再帮你询问原厂。Okay, and it's really an honor to invite the Beckman many about this bioreactor introducing and sharing the bioreactor this time. And we have the same. So very thank you. And we'll say goodbye. Thank you, Joseph and Alice. Bye bye.
OK，谢谢，拜拜，
拜拜。好的，那因为今天如果还有很多的问题，相信大家对于这台机器有非常多的疑问呐。那如果真的有任何的问题的话，再麻烦大家扫一下这个 QR code， 然后填写一下问卷。那在10月25号以前的6点以前的话，再把你们的问题全部都放上去。那到时候有任何问题，我们都可以再跟那个 Beckman 他们去做询问。那非常感谢大家今天花了非常多时间来听了关于这台机器。那如果有任何问题，那我们之后在会后见。好，那我们今天的那个BioReactor 的一些分享就到这边，谢谢大家，拜拜。